loop antennas. So, Victor, if you don't mind, let's go ahead and Jim and I will explore loops. Now, a small magnetic loop antenna can be receive only or transmit. And the transmit is critical because there's a lot of stuff that's slightly different in the transmitting loop than just the receiving loop. So what we see here is about 1/8 wavelength for slightly different in the transmitting loop than just the receiving loop. So what we see here is about 1/8 wavelength for uniform current distribution throughout the loop as a lumped inductance. That's the loop itself. Maximum power will be a figure 8 in the plane of the loop. So right now, if we were to look at that loop, we're not hearing much power. And the short whip or a short dipole is capacitive, and we normally load them with inductance. This lowers the Q, ups the losses, and conversely, for the very high Q and lower losses found in the loop does a marvelous job when tuned in properly. And Jim's going to tell us all about what it takes the mic make the right type of loop. So narrow bandwidth, maybe only 10 kilohertz at 7 megs, but the high Q parallel tuned circuit in a loop gives us incredible gain. Now, to minimize lumped I²R conductor and capacitor losses that go up in heat, and of course going up in heat means losing energy, here's a ham that homebrew the losses to a minimum by using wide copper windings and a vacuum variable capacitor, and this is going to give high intrinsic radiation efficiency. Now, these loops can take about 100 watts of power or less. These, and Bob, you remember seeing them at Xenia, Ohio Hamvention. This particular loop can take probably 300 to 400 watts because there are tens of amps circulating within this loop. And notice at the very top of the loop are the big capacitors. And the capacitors are the key to making a loop antenna play. And of course, the nice thing about a loop like this is that it's portable. It doesn't mind being at least a loop above the ground, no lower than that, but just one loop distance from the ground is all it takes because the loop does not rely specifically on ground currents. And the loop has both a low as well as a high angle of radiation, and one wavelength loops, the really huge ones that Bob and Don are going to put around their property, they radiate perpendicular to the plane, but this vertically polarized magnetic field within this loop is going to radiate in the loop direction that you see it there. So think of the loop as like a magnetic dipole, whereas an ordinary dipole is an electric. So the higher the Q, the lower the noise, and on transmit, that means no harmonics, and that's a neat thing. Now, loop efficiency is equal to conductor tube diameter and conductivity of skin effect. So the loop of those pliable loops that are great for packing in your vehicle, or as Tracy of the MTARA team does, he sticks it all in a neat backpack with the Alex loop. Flexible conductor low-loss coax is a great way to go, remembering that a square root of frequency law. So the better the conductivity of the loop itself, the better that we're going to have a good signal being radiated. Well, a fat tubular conductor with the within the loop element that's smooth and is going to have almost no eddy currents. And you may say, oh, it's not copper, it's aluminum. Well, aluminum has a DC ohmic resistance of only 1.6 of copper, that is DC, but the RF skin effect of both copper and aluminum are close. copper, the skin effect, the signal only gets 20 microns into the conductor, whereas the aluminum is only a mere 26 into the conductor. But what really makes the difference on the loop antenna with a solid conductor is this right here, and that is the junction between the two conductors with nothing more than a wing nut and maybe a couple of washers that are seated well. Because the magnetic loop has great radiation, but resistance of just a few hundred milliohms. One added milliohm will equal one loss of efficiency. So that's why we want to make sure that any loop connection that you see like this is going to work out as a very low resistance conductor. So the loop at each end of this particular circuit goes to a series capacitor, transformer coupled, and the unshielding coupling loop, that's the one that we put the coax into, is ready to roll. And Jim is here. And Jim, how about telling us what you do on your homebrew loop out of copper to make sure that each and every one of those octagonal joints is not going to have high resistance? Jim?
Well, this is an 8. Of course, this is an 8 section made out of 10 feet of 0.9-inch diameter copper, and you braze those elements together with this. It's called silverloy, and silverloy is available for about $2 or $3 on eBay, and it's 80% copper, 15% silver, and I think 5% phosphorus. And you use a very, very hot brazing to get it on there, but it's easy to do.
Wow. So now you have an octagonal loop, not quite as efficient as they say a round loop, but you've had good results with this, huh?
Absolutely. And that's great if you've got all the materials to bend all those, but if you do a good job, I think the difference is something like 5%. So it's really not a big penalty to pay there.
Wow. And as you'll see, Jim is able to get this in his vehicle. Now, the key to getting the signal to be inductively coupled to the loop is this 5-to-1 smaller loop, sometimes called the primary, very similar to the primary of a transformer. And the primary concentrates the magnetic flux lines which cut the small untuned feed loop, and that equals higher Q, especially on 7 megahertz, but a slightly lower Q as we go higher in frequency, but the efficiency actually is greater. So the impedance of the main loop is independent of frequency, and this little feeder loop run right in line with the main loop is what it takes. And this little feeder loop comes in many different configurations. Jim, you did your own, huh?
Yes, I did. And just a piece of RG8X, and it seems to work just fine.
Absolutely. And Jim and I did some playing around because we had read on the internet that you could reduce SWR slightly by mooshing around the bottom of the feeder loop. And yeah, we saw a change in the SWR, and that change did make a slight difference, but it really didn't in the performance. Now, when folks homebrew their own loops, this is wonderful because remember, these small loops will work great in a condominium backyard where you're not allowed an antenna, yet the loop will put out a signal almost equivalent to a half-wave dipole mounted too low to really be effective. And here we see that primary of the transformer feeder loop that is just above the bottom of the main loop. loop. And that feeder loop placement is very important. Here's one held on simply by Velcro, and it's fine. And, it didn't really seem to make a difference whether it actually contacted the main loop or not. It was just the inductive coupling that really makes a difference. And by the way, that main loop, the big part, is about 1 meter, about a yard, for covering 10, 15, and 20 meters. And it can also cover 40 meters, but you're going to need a larger, about a 2-meter diameter if you want to get to 60 meters and maybe 80 meters. And if you plan to do 160 meters, your efficiency on a loop is not going to be more than a micron of 1%, but nonetheless, it would have to be as high as 4 meters in diameter. And critical is keep that inner loop perfectly aligned with the outer loop. The inner loop is inductively coupling to the outer loop, and it must be perfectly in line. Now, this is Carl Lavoie of Chameleon, and I said, Carl, can you set us up? Jim was watching in a few seconds or less, a few minutes or less, and bingo, he did. And that's using coaxial cable. I think it's LMR 400 with a solid conductor, so we have good symmetry of that outer loop. And again, the feeder loop is that loop that is on the top. Now, on the bottom is the tuning capacitor. And, he's got calibration lines as well as a toggle switch. The lines were not perfectly calibrated, but you tune that big knob quickly, and when you hear the noise really come up, that's your sweet spot. Now, for 40 meters and 60 meters, where Dale and I work U.S. Coast Guard auxiliary comms, we flip the switch, and I believe that's going to add on to the left what is probably, it's supposed to be secret, a capacitor that adds more capacitive reactance to get us down there. Now, this is John Miller, N7 Juliet Delta Mike. He is the one that is very familiar with what's inside the sealed box, and you can contact John at support@chameleonantenna.com. And he's a real good guy, and he says it like it is. So if you're having a problem, especially with one of his loops, he'll tell you what the deal is. Jim, I'm looking at it, and it looks like his feed loop is not in line with the main loop, but maybe he's doing that on purpose. Jim, what have we got here on your homebrew loop?
Well, on top there, that's a fixed capacitor in parallel with the variable, which is necessary for 40 meters. So if I do 40 meters, I put that on and take it off. This is at the top of the loop, and some designs have it on the top, which has got an advantage and disadvantage. The pro is that you don't have to have any magnetic decoupling from the coax if the loop is on the bottom. But of course, when it's on the top, you got something that's top heavy. So pros and cons, like everything else.
Oh, that's great, Jim. And Jim, here's another closer look of what we've got going on with that great connection at the top of the loop. And we'll get to that in just a moment. Victor, if you'll go to that next slider-rooney. There we go. Jim, what have you got the copper foil on?
Well, that's right across the aluminum section. This is a 2-section capacitor, and the capacitor, the connections are not to the rotation portion or the rotator. It's to reduce any losses because of the rotating joints. So RF does go through the aluminum, so it's bypassed by copper and reduce the losses.
Wow. Well, you've done a great job of that, Jim. And now tell us about the makeup of the capacitor. Boy, it looks pretty close for more than a few 20 or 30 watts on this one.
Well, these are actually, it's two 200 picofarad, 2,000 volt capacitors. And when you hook them in series and just to take the connections from both ends, then it becomes 100 picofarads and 4,000 volts.
Wow. So likely we could run maybe 50 or 60 watts?
Well, I did okay with 100 on 40 meters, so I think that's, but it calculates to almost just very close to 4,000 volts.
Wow. Well, that's terrific. And, of course, we encourage all of you to think about making up your own. And there are so many great websites, plus that article in CQ, current issue of CQ, that talks about the relative efficiency of a small loop that you can put in your backyard. But this is great where they're using wide copper foil as well as that vacuum variable. So, Jim, you do what? You're tuning in on 40 of the smaller variable capacitor, right?
Yes, that variable capacitor is always in there, and that's the one that'll tune from about 10 megahertz all the way to I think it's 28.7 or something like that. Without the top one. By the way, the top one's about 140 picofarads, and it's also rated, I think it's 5,000 volts.
Wow. So next time you're at a swap meet, be sure and find an extra one for Gordo and Jim. And Jim, what have we got here?
That's the tuning indicator. Should you use that, but it works.
Yeah, a little NE2 neon. I bet it lights up nice and bright, and you've done a great job with that. Now, here's a motorized one that we have at Quartz Fest each year, and it's remote controlled, so they can go ahead and do the tuning via remote. And for those that are thinking, gosh, this might work great in the attic or in my backyard, but I don't want to be running back and forth. Well, Chameleon has an answer, and I know other loop manufacturers do, and that is taking this particular device, tying it to a tripod, and one set of commands via the line will turn it, yet the other one will go ahead and tune it. So pretty neat that they have this little tripod that you could put in the backyard or up in the attic or somewhere where no one else will see it, and you're able to both tune as well as turn that loop antenna for best results. Now, you can also do it via the Chameleon down at the base, and they have a little adapter that instead of your hand, it is that automatic one. And Jim, how'd we do on comparison between like the $500 loop in the foreground and your relatively straightforward loop in the foreground, Jim?
I think I did pretty good. I think but I think they both work fine. But I mean, mine's copper, and it's maybe even a couple inches bigger, but it did good.
It did. And what we always encourage is be sure and watch the RF eddy currents that can creep down the feed line, right, Jim?
That's right. And that's the reason why I have my loop on the bottom. You don't have to do that because it's below. And that's one advantage of having the loop on the bottom versus the top.
So you're not going to need a whole handful of chokes to try and get rid of that. In fact, the Amadon Mix 43 or Amadon Mix 61 with a mu of 850 allows that RF to stop right at the chokes, and even a little rep like that will help. But this is what we do to keep any eddy currents from transferring over to the loop. Now, Jim, how about the Q down on 40 meters? We got like 100 kilohertz?
Well, I think it's more like 13 or 14 kilohertz for 2 to 1.
Here we are on 7295 and a half, perfect SWR. And when we go up maybe or down a few kilohertz, what happens?
Oh, there is 2 to 1 right there.
So this really points out that the loop has great efficiency, spot-on frequency on transmit and receive. And on receive, the magnetic loop does not pick up electrical vertically polarized signals because it is magnetically. Now, we compared the loop to the high Q antenna on the back of my wagon. And first thing we discovered was the loop was too close to the wagon. We've got to keep that loop absolutely in the clear, as you'll see in just a moment in Jim's backyard. But you can see that the tuning is on the bottom and the matching is on the top. And for Chameleon, they have both the hard aluminum loop as well as the one that, as Tracy will recommend, that has coaxial cable that allows you to go ahead and take it. And, of course, when you're tuning the loop, you got to tune it and then what? Step back a bit?
Absolutely. You interact with everything.
So here's a fellow in the tuning process. There's Jim pointing out the portability. Does that fit in your car?
Yes, just barely.
And Darcy, his wife, loves that. It gets stowed in the trunk. So we encourage all of you to think about the possibilities of the loop. It does not have to, the portable loop does not have to be mounted more than one not wavelength, but one loop distance from the Earth. For those that have a great Earth like sandy soil that we're going to have 2 weeks from now during our Thanksgiving on the air on 20 meters, 14335, we're going to be testing different loops, and you may hear Jim's loop, the Chameleon loop, and many of the other loops that you see advertised in the DX Engineering catalog. And so, Jim, the loop is in your backyard and it's playing, huh?
Yeah, it seemed to be working good. And I also used at one point a tripod of PVC just so it wouldn't, and this one before I did that, but just so that it wouldn't introduce any losses because of the tripod. Now, there's probably not a lot there, but I'm trying to pay attention to details here.
Wow. Well, that's a real detailed loop. And so 2 weeks from this Thursday, Thanksgiving Day, 14.335, Chip Margelli, K7JA, and Gordo will be comparing our loops to, well, not necessarily a two-element beam, but we're going to be comparing our loops to a regular dipole antenna. And here's Tracy. And Tracy and I were, and Susie and Jody were up in the mountains off of Highway 49, and we had a great time. And as you can see, his Alex loop set up in just moments, and because there's no metal around to detune it and create eddy currents, that loop just did a great job. So we sure encourage all of you. Jim, any final words on loops?
Experiment.
That's right. And have fun experimenting and see what works, give signal reports. And 2 weeks from now, we'll look forward to hearing you on the air, 14.335 on Thanksgiving Day. So put down the turkey bones and get ready for the loop.